The future of laser first down marking is here.
There's an Albuquerque man who hopes to make his own impact on the NFL, college, and high school football. Norman Hardy says he will do this one first down at a time.
New Sports Technology, NST, has spent the last 12 years researching, developing, and perfecting the biggest sports invention of the decade. NST has the patent, the secret, and the solution to the old, antiquated system of measuring a first down on a football field.
Invention USA. Linesmen have been using the old chain system to measure first downs for over 106 years. If Norman Hardy's invention works, he can change the game of football.
The NST laser system is a laser first down marking system created to modify the traditional chain gang measurement system in football. In Norman's system, the chain gang will still move the chains along the sideline, but instead of running the chains and markers out to the ball, the laser, which will be encased in a protective carbon fiber pole, shoots a beam from the sideline to determine if a first down has been reached. Inventor Norman Hardy claims he has done what many said was impossible by getting a lower wattage beam to show up in daylight. This is thanks to a target that uses a patented reflective technology that Norman invented called IMARC.
The NST laser system is the first to produce a proven system that is accurate, instantaneous, inexpensive, and best of all, it really works.
It's time to put it to the test.
The idea of Norman's invention makes a lot of sense, but is it sound? Laser technology is only fail-proof in controlled environments, so we need to test the NST laser in conditions that mimic the bright sunny afternoon in Candlestick Park or a snow blitz Lambeau Field.
Check this out, guys. This is awesome. Behold, the gauntlet of weather. You guys up for the challenge?
Absolutely.
Oh, yeah. You nervous at all?
Not even.
All right, let's rock. Okay, we're gonna do the light test first.
We all know that lasers work well in darkness, but when it comes to bright light, they can be difficult to see. So on top of using the sunlight on this bright day, we're taking it a step further by bringing in a few high-powered floodlights to dilute the laser as much as we can.
On the count of 3. 1, 2, 3. Right on.
Well, lighting up the field didn't even affect it at all.
Not at all.
So, Connie, go to that last light. I want you to point it at the target
Okay.
and move it around a little bit so I can see what that does.
Flooding the laser with light did nothing to the NST, but I wanted to see what would happen if we hit the target with a direct blast of light.
There you go. Wow. So even fully lit up, I can still make out the beam.
This is wicked bright, man.
That's pretty impressive.
So you feeling the love?
I'm pretty impressed by that.
That's one, Mr. Science. Not so bad.
Norman, I was really impressed with that light test. Now we're going to throw some rain at this, and then we're going to throw wind at it as well. Are you ready?
Absolutely.
Turn it on.
It is a little scary. You have no idea. It could be the end of it. It could be the future of it.
That was actually really interesting. So when the water came on at first, I could see the laser actually dancing a little bit. And when we threw even more wind at it, of course, it made it a lot more turbulent out there. That then made the laser not just bounce, but of course it would focus up.
Exactly.
But it works.
But it works.
You passed the test with the rain, and now we're going to do light and snow.
So far, Norman's invention is 3 for 3 in our tests, but this last test is going to be the one that makes it or breaks it.
Rock and roll.
Okay. 1, 2, 3. And the clumps of that are the size of your nose.
Wait a minute. There it is.
I don't see it budging.
Even when it's sticking to the board itself, which will really happen, I still
good.
see the line. That was a really good test. I like what I saw.
That was a great test.